Hi guys, welcome back to my channel. First time viewers, always welcome. I'll be discussing how the internal extractor and ejector works with relation to the ejection and feed systems of a 1911. There's been an awful lot of market add-ons from the OEM, and I just feel it's just largely dangerous and unnecessary and highly problematic. And you'll see why when I walk you through this. I've been working on these guys for well over 20 years. And there's very few people, very few people that that I can hang with when it comes to that kind of reliability. But that's okay. I'll hang out with whoever. I like people, good people. But so getting to the point, I have 1911s here. Both of these I've made. This one was a spare parts build out of rusty, surplus parts. Used to be an auto ordnance. It's got some Colt parts in it. It's got all different kinds of different mayhem in there. That's usually better than factory. And I don't look like much, but it's had over 1,000 rounds. And this slide's harder than most people's slides. Not to give it bragging rights, but it's incredibly hard. And if you were to buy a new 1911, your slide would be nowhere near as hard as this old auto ordnance. Para ordnances tend to be really hard too. But anyway, not to go off being a braggart or anything, but give you a little bit of idea before you spend your money. This build set me back something like $330. And you've probably seen it in my other videos, but this guy here was a complete build. I got a frame and I fitted the slide, and this thing was the tightest thing that you could ever imagine, and it still shot loose after about 2,000 rounds. And then of course I painted the slide. It's not like your traditional kind of finishes, because finishes typically are a problem on 1911s because they make the parts stick, gum, and bind. Oh, excuse me. Unless they happen to be, a solid stainless or material that's not plated. Plated materials, you have to be careful about your cleaners because they'll flake off and cause jams, and they'll actually cause a lot of harm to the metal in tight spaces. So I have a different perspective on building guns, So this is what 2,000 rounds look like through a super tight gun. And hey, guess what? It's loose. Check that out. There was none of that when I started shooting. But that's just the nature of the beast. You could throw all your money towards a really high-end 1911 that's super tight. And guess what? It's going to shoot loose. I guarantee it. Doesn't matter how much you paid for it. It's the nature of the beast. And nobody's 1911 will ever be super tight for very long. It's just a matter of mileage. And, and usage. Whether it's shooting or cleaning, thing's going to rattle loose. So, getting to the topic, what we want to do is we want our guns to feed. We want to get this in the gun, and we want it to go bang, and we want it to exit the gun. So we have our barrel, and a lot of these reloading manuals tell you that head spacing is really important, for accuracy. And it is. They're right about that. But they're also wrong about what head spacing actually means in relation to head spacing. And most often they're wrong because they want to measure the overall case length kind of like from the chamber. I can tell it goes in there quite a ways. And then even if it is in there, there's some wiggle room, some chatter. Some of that chatter is the dimensions of the chamber, and which contributes to the reliability factor along with the throat to the chamber. That contributes to the chatter. 1911s lock up at an angle, so that could be really challenging on an extractor claw. You might notice how the rim is like 90 degrees to the shell. So if you think that your extractor claw is going to be 90 degrees, and this guy is going to be like this in full battery, and it comes down and goes up, it's got to work with that claw in the way it's contoured. So what I mean by that, from a critical view, not only from the feeding aspects of it, because head spacing is not done completely, in the chamber. What they're trying to say is the closer you get the bullet to these little grooves and the lands and the grooves, the more accurate it could be. What I mean is when this round goes off, it's going to swell. It's not going to be straight in the chamber. More often, it's going to be off center when it goes off because of the looseness and the way that guns go in the battery. So that's why a lot of people like once fired brass, because the brass just does its own thing. And when they trim it down, there's a reputation already established in that particular round that you reload that can give you better results than factory. Because factory brass, you have no idea how it's going to stretch out or, that sort of thing. Because they act like balloons when they swell. They go to the area of least resistance. And gun shoots both forward and back. That primer cup will move on you towards the flat of the slide. That's why you might want to have your slide closed when that thing goes off, because that primer can come back and take an eye out. And it's not often discussed, but it might be something you might think about if you want to buy a Beretta M9 or 92 SF, because there's not a whole lot of slide back there to stop that from happening if the bullet doesn't chamber. I'm not saying it does happen or it won't happen or whatever. I'm just saying that that's an awful reduced slide to be a combat weapon, and I wouldn't feel comfortable from being behind it, honestly. So typically natal rounds, the primer cups are crimped, but once again, getting to the point of the matter. All right, so we have our magazine. Put our bullets in there like that. I'll put it in our gun like this. All right. You really should not be using live ammunition, but I don't have any dummies here, and I'll just be careful, So I'm going to point it in a safe direction. Don't point at anything you want to destroy, because you will destroy it. And all guns are loaded, so you can't really rely on safeties too much. The safety is your practice. Your practice has to be perfect. So anytime you add external safeties and whatnot on the gun, it just adds a complacency that's incredibly dangerous to the user. It's better if somebody were to try to snatch your gun type of scenario than it is for you to have on there just for your own comfort, because when you rely on it, it might let you down. That one extra push, you may not get the chance. And they also snag a lot. So that's something to consider if you like the concept of a lot of safety features on your gun. Safety features always, I can't say always because there probably might be some exceptions to the rules, but typically on 1911s, if you put any kind of safety anywhere, it's going to snag. So, all right, we got a round in there. It's heading for the chamber. It's got to go up that feed ramp. So you know it's going to be like skateboarding up that feed ramp. It's going to go in that chamber. It's going to go up like that. So that extractor claw has to be like this, and also has to be like that. So the round can go up, in, and then, you know, elevate into battery. So this is what's going to happen. Okay. It's chambered. It's loaded. There's a safety feature. It's so little, I'm not going to rely on it. All guns are loaded. So let's get this out of here so we don't complicate what I'm about to show you. So when I pull this back like this, you're going to see the round. It's held by the extractor claw. And you can tell there's a little gap there for the round to float. And that's necessary for reliability. And then you could pull it back. It'll hit the ejector. It'll come up. You see how it's clearing the hood? And out. Like that. Come on, brother. Fall out of there. You're making me look bad. The next one goes in. That one kind of hung up. And then I'm going to pull it back. See how it comes back straight-ish? Well, there's not a round on the bottom of the magazine. This is the last round. So it's coming straight out. So you're going to hit the ejector. Come out like that. There we go. Lock, slide back. So not having a round in there affects the way this thing ejects. Because remind you, there's a space, you know, between the head stamp. There's a head stamp back here. And the breech face of the slide. So that extra space is necessary for reliability for ejection because it creates the clearance for your round to hit, come back, hit, rotate like that, and out. So what that means is this guy here should not be sharp and square, like a 90-degree surface. If you look at the way the light dances on it, it's not 90 degrees. It's actually kind of rounded. It's kind of like, it's rounded back, radial used back like this, which causes the upward rotation of the spent shot. And when that happens, your extractor, this guy right here, has to allow that rotation. So it's going to go out like that. It's going to rotate up. If there's a round in the magazine, it's going to help lift it up, rotate it, and out. It's going to give the upward heft. And on the 1911, the magazines don't square up. There's a lot of play in there. Like this. So you got some chatter and some play. That's not a big deal. I guess it's really not that much, but there's a lot of paint on this thing. So anyway, it lifts. It provides a lift off for the rotation. So it's kind of like giving it a head start. Kind of hit that. You guys are going to be experts after this video. So it's going to hit this. And it's going to rotate kind of like this. and out. So this provides a lot of upward lift. So when the lift isn't there, you can have a lot go wrong if your parts aren't adjusted and fitted correctly. So that last round could be a problem. So go up into the chamber, and it comes back here, boom, right here, rotates up and out. So this surface being angled like that and feathered back at an upward rear angle, knocking that corner off slightly, causes the empty, I get that in there. All right, so yeah, my extractors are really tight. You know, if you buy a 1911, it'll be set probably anywhere between 2.5 to 3 pounds of pressure on the extractor claw if it's an internal, such as this one, but it won't be like mine. Mine's pretty tight. Whoop, it just gave way. No, it didn't. That's not a terrible thing. It can be, because if it's set that tight, it'll have a tendency to really wear this surface here. They'll start feathering back and burring up, cause a slide jam. What? Did you hear that? A slide jam. Well, dang, how do I prevent that from happening? Well, if it's going to be feathering back, because your extractor might be set a little tight, well, why not just make it that way? You know, and then it won't continue to feather and burr upward. Well, hey, that makes a lot of sense. Well, why don't 1911 manufacturers do it? Well, it's because it's time consuming. You know, people want tight guns, so they're going to make tight guns, and they're going to jam. That's all there is to it. You know, there's some common sense to this. All right. So I think you got that. But in relation to headspace, like I was talking about before with the chambering, how they measure the overall length, and it's crucial. So you don't want a round that's too long for the chamber, because if you try to chamber it, the shell can crimp at the bullet mouth and cause an overpressure, and it'll just blow up. So when you do your overall case lengths on pistols, revolvers are different and rifles are different. You want it to be a little bit shorter than their maximum overall length. And you don't want your shells to be so long that when you fire this thing, you know, and this firing pin that sticks out is hit. This is a floating firing pin, so it travels. And let me flip it around, maybe you can see it a little better. Okay. I don't know if we can see that guy down there, but you can hear it tapping the primer. I'm not doing it hard because I don't want this thing to go off. That'll be the end of the video at my channel. But this extra travel here, you know what you're seeing here, if I can get this firing pin, it's real stiff. I like my springs stiff because I want them to be reliable. See, when it hits it, this guy can get up off its seat here with the extractor claw and move forward. Yeah, move my thumb there, see if I can get that kind of result for you without blowing the place up here. See that? The round pushed forward safely and nobody got hurt. Don't ever use loaded ammunition, and don't do what I just did. I just did it so you can understand. And then I've got a lot of stuff in the way here that you're not seeing. Anyway, so what we see here is we see the bullet moving forward because of the space on the extractor claw. The extractor claw moves on these guys. It provides a little bit of space here for that locking and unlocking of the projectile, the feed of the projectile, and the ejection of the projectile. So having space behind the shell and the breech face is critical for that kind of reliability. And these parts here on the back tend to be kind of loose. See that mine seems to be a little tight. I think it's probably because of the paint. I haven't really shot it or abused it as much as I should to get that stuff to loosen up, but I wouldn't try that on a new gun because I already know what can happen. So these parts here, there's a little bit of movement with them. Every time the hammer hits this back plate, there's a few thousandths of an inch of wiggle, and that transfers to the internal extractor. It causes movement and vibration of the extractor to go like this. When you hit it, causes a forward aft movement. And then, after the firing pin does its job and it comes back, there's a little bit of wiggle there. It pushes back on the, this plate here that retains the firing pin and also retains the extractor. If you see your extractor on the back here, this flat is, if you see it sticking out down here, instead of being straight like this, like what you see here, if you see it a little bit like that, that's not good. Or if you see it a little bit like this, that's not good either. Because that back and forth like that, there's a term for that. It's called clocking. Maybe it's not in the gunsmithing manual or it's not taught in class, but that's typically what is referred to, in the 1911 building world. So you don't want this thing rotating this way or that way. You want it to be kind of fixed, but a little bit of forward and back movement, tiny bit, like maybe 2 to 3 thousandths of an inch is not a big deal. It actually helps things along the way. And you don't want it tight, because if you have that tight, what can happen is when you, let's see here, drop around in here, which is something that typically you never want to do with a 1911, and you let that slide slam home, on top of that, that claw will climb over. Come on, brother. Killing me. There we go. It'll, what was I saying? If you let that claw trail over that, that extra 4 pounds of pressure will pre-fatigue the extractor claw. It'll take the tension out of it. It could also rip the rim of the shell. So you don't want to do that. But I see a lot of people do that. There's a lot of military people that do that. Oh my gosh, you have no idea. And excuse me, empty slide drops are just as bad on a gun. But that's okay if they want to do that to their own gun. But sometimes I have to do it with mine because I don't mind breaking them because I can fix them. And I'd rather fix them my way. Because if it broke, it tells me there's a problem with the manufacturer and the design. So I have to fix it because I can't have a gun breaking on me. So you want a little bit of, forward movement and, forward and reverse there, forward, aft, whatever you want to call it. But you don't want too much because, like I was saying, if this pin is so tight, this pin keeper, retainer, firing pin, housing, plate is so tight that you don't get a little bit of travel there with your extractor. You can pre-fatigue it and you can also break it. That little bit of forward and back saves your extractor from pretty bad damage that can happen. And so getting to the head spacing issue with this firing pin is when it pushes the round forward, it also pushes the bullet forward into the chamber, and it can cause the bullet to smack the chamber shoulder and cause it to crimp. And when you shoot this sucker, it could blow up. So getting back to why I'm retracing to this lesson here, I want to impress upon you and have you understand that the extractor moves forward and back a little bit. And it does that to prevent it from breaking. So if you drop around in here, like I had showed you, and you snap the slide, what happens is it could force this guy to, like if it's right here, the extractor claw right here, it can hammer it, causing your crimp to fall in and crimp more, create an overpressure, and cause it to possibly explode. 45s is kind of hard to get an overpressure with these guys because ½ inch is pretty big, and 45 ACP pressures you got a little bit of leeway there depending on the powder you use. But that's something that you must understand with extractor claws and case overall length and head spacing. In the reloading manuals, they tell you that this is important. Yeah, it can be important so that the shell isn't longer than the chamber, so it doesn't crimp in there when it chambers and blows the gun up. Likewise, you don't want the extractor claw smashing into it and then causing it to crimp in such a way, depending on what kind of powder you use, it can cause the gun to explode. Although I haven't seen it happen yet, it's not to say it won't. That's just something for me to check the box when I see it happen. I've seen a lot happen, but that's one thing I haven't seen yet. I don't think I really want to see that. But typically what happens is it's very hard on the gun. Just like if you didn't have a round in here and you snap this thing closed, he has a tendency to break the way that the cradle is in the way it comes in the battery, and it'll start shooting off center, and you'll get a little bit more chatter. But hey, if you like that kind of thing, yeah, go ahead. Keep doing some empty slide drops and you're guaranteed to break apart. And don't think that because you have a Glock, you're not going to break it, because I've seen locking blocks break on Glocks because of that very same thing. I'll get to that in another video. But so by now you should understand how case overall length, head spacing, floating firing pins, and a little bit of wiggle on your extractor is crucial to the success of your gun. And tightness in all of these areas could be really problematic. You know, it's all right to have a lot of extractor claw tension if your ejector is fitted correctly and profiled correctly, not being squared or round or pointed on its tip. You know, you could actually run a stiffer extractor and not have reliability issues where it's going to cause the back of the round to peen on the ejector and cause the slide to jam. You know, jam on a burr. You might notice how the paint's gone right there. You know, there's a lot that happens right there. And I probably didn't clean it too good here, but oh well. I can always paint it again if I want to. So, all right. So, I hope you got that. Okay, so there we go. I covered the lift of the magazine, the ejector, the extractor claw, the firing pin retention plate, clocking, and head spacing, case overall length, all that goody stuff. Okay, so now let's get to the point of the matter. We're going to remove this plate. So to do that, you push in the firing pin, and you drag the toothpick. Dragged it. All right, you. I'm going to get it just yet. You wait. I'll push this guy in. See, I beveled my firing pin right here to make it reliably fine and retain the plate. And it just makes it harder for me to take it apart because it works so good. You might want to do that to your firing pins. Because if they burr up, you know, they could stick out. They could stick out like that. And you end up with a slam fire. So every time it chambers around, it's going to be like a dangerous situation. And you could get in trouble with your local ATF if you're in the United States, because they'll go full auto on you. And you're going to have a hard time explaining that one to the feds. And you might end up losing your gun and having a court date. And it's going to be kind of hard to explain how that happened out of 1911, being as so old and time proven, and you were the first one to make that happen. So, oh man. So anyway, yeah, that beveling on there is creating some problems for me taking it apart, but here we go. Going down like that. So the firing pin is out of its hole. So now I can move the plate. This guy's going to shoot off straight because it's spring loaded, even though it's a floating firing pin. I want to move it a little bit so I could see the pin right there. That's the pin head. Okay, I'll move it a little bit more. It's right there. Now we can see it. If I take it further, it's going to shoot out at me. So I want my toothpick to be flat. I want it to grip that head as best it can. Push her in. So this plate will fall out. And then I could slowly ease up. Like this on. Like that. Ta-da! Alright, so there's my firing pin. It's got a little bit of toothpick on it. Some 1911s use titanium. It's a very bad idea to use titanium parts in the firearm. They're not durable, and they gall and wear out incredibly fast. They might be strong and flexible, I'll give you that, and lightweight. Like a lot of 1911s that try to be California compliant, they want their firing pins made out of titanium. But if you do that, you're going to want to make sure you have a heavy hammer that hits this thing so you have enough inertia to set that primer off. Because, you know, titanium's so light. Let's see which one of these. Yeah, I didn't really make an indent on there when I was showing how those firing pins push the rounds forward. Okay, so we got our plate off. You know, this is a part that almost always gets forgotten about. You know, when people fit parts, they just throw a part in there and they call it good. And there's a lot of detail to this part that you're going to want to do if you want your gun to be reliable. Now, mind you, the slide on a 1911 has a float to it. You know, when it's balancing on the bottom of your barrel lugs on the slide stop pin, and if you have your bushing set correctly, you'll have a little bit of pressure on it. This one is correct. You can see all the correct wear patterns. You can see the bearing surface on the top after the slide, you know, hits the frame. You can see that the plug is worn in 100%. It has the wear pattern. And then you could see the back where it sits in the slide. So the recoil spring, you know, pulls the slide forward. And this is a correctly fit bushing. You know, I had a video on that, but you might want to check it out. But that's what a correctly fitted bushing looks like in a 1911 that's reliable. You know, I probably have a lot of people argue with me about it, but that's okay. Your gun jams a lot more than mine, I guarantee it. So, where was I going with this? Got a little sidetracked. Yeah, so when this guy comes back and smacks it like that, it causes a lot of vibration. And that vibration transfers to the slide rails, and you end up with a rattly slide. The 1911 slide is weighted for a recoil pulse for the 45 ACP cartridge. That's why 9mm doesn't work so well in the 1911. And they'll probably have some people that don't know any better arguing with me, but that's the reason why it doesn't work that well. Because, you know, even though 9s, you know, have that sting and all that, you don't have the type of blowback that you do with a big heavy bullet going down the bore, and the shell pushing on the back of that. There's more surface area on the 45. So, but anyway, to his own. But so when this guy, oh wow, I didn't have the plate in there. So this float here is a result of the slide trauma when it hits the frame, because it's supposed to kiss the frame, you know, and that vibration knocks the crud out of it, and the flaky paint in my case. But because of that, it's got, you know, back and forth, up and down. Still hits 25 yards within 6-inch groups at 25 yards, so it meets all the combat specifications. Probably does better, although I typically don't engage targets at 25 yards, because if you do that, you're going to find yourself in a lot of problems legally, because it'd be kind of hard to mitigate a self-defense claim if you can hit targets at 25 yards with that degree of accuracy. But anyway, hey, if you can do that, man, you got my respect. I just know your life's going to be difficult if you decide to engage a threat at that distance with a handgun. Okay, so what that means is your plate, you want to have this thing not so one-directional. You know, you could see how the way that this thing is, you know, it's contoured. It's kind of like rounded-ish, but not quite square. So when the hammer hits it kind of like in the center of the plate, and energy isn't wasted on on the side of the plate because of the shifting of the slide, when it goes in the battery. The slide float, so I don't want wasted energy from my hammer when it hits the plate. So that's why it looks like that. And if you see in the light, there's a shiny trace right down the middle, right there. Well, not quite the middle. It's in the right spot. And that's where you want it. And then you want your hammer kind of reflect that. So typically hammers break down here. You see it a lot of times on the heavy use ranges. You see a lot of combat shooters in the military or what have you. They're used to having those hammers fall off. So ideally, they'll break right there. So ideally, you want to have them stress relief, meaning you want to dress them back so that your impact surface right here, I don't know if you can see in the light, there's a little bit of galling right here. Right here, that's where the metal hits the metal, and then it trails back up here. You can see a little frosty triangle. This is the area that hits the firing pin. So when this hits the back of the slide, it hits center in the hammer. So if the pins decide that they're going to relax set in a way where the hammer is not going to be straight, it's still going to home in where it needs to be to put the force where you want it. You want to use the force. I don't want to put it in terms like that, but you want to use the force in its applicable form without wasting energy. And that's how you do it on the face of your hammer. You don't want any hammer spur trailing back like that that's heavy, because what's going to end up happening is your hammer is going to have some float on the pin, on the hammering pin. It's going to wear the hooks, and your so good trigger pull is just going to go out the door. You're going to end up having catchy hooks, which is why on a lot of custom guns, they don't want you to know that. And that's the main reason why you see like this area of the hammer is skeletonized, because when that hammer hits, you can, that vibration, comes down into the frame, and it does unhealthy things to your sear. And your sears typically tend to be a lot harder than the hammer hooks. So they bite into them, and you end up with this hourglass wear pattern. So what all these high-end gun manufacturers do to prevent you from knowing that is they reduce the hammer hooks. So when that happens, it doesn't feel so catchy to you. It can be dangerous, but there's a specification for that they consider safe. So I wouldn't mess with your hammer hooks at all. I would not mess with your sear at all. Just make sure whatever hammer you get is the lightest possible hammer you can get, because your trigger pull will be constant no matter how much you use the gun, and it'll also feel good in the hand, because then you'll end up having a really light pull, like such as this one here, where it don't take much. I have no idea how heavy this pull is, but I'm just touching it like this, just a little touch, and it goes off. It's probably like 2 pounds, or maybe 1.5. Not bad, huh? But you don't even feel it when it takes off. I don't even feel the sear to hook engagement at all on this thing, because it's so light, and the hammer spring is not as strong. So when you run hammer springs or main springs that are less than the OEM recommendation, you increase the probability of accelerated wear on your parts, because they chatter more and they vibrate more. So by now you can understand why this is the way it is, where the bearing surface is the center of the part. And when you look at the wear pattern here, you can tell where the hammer is hitting right center. Maybe a little off this way, but that's okay. It's exactly where I want it. And then you want a little bevel on the top of this guy here to help you with your assembly. And what you're seeing here on the side is bite marks from the extractor claw. You know, it's from me when I've had jams. When I had jams, you know, and I just snapped the slide to pull the shell out. And what you're seeing here is when the extractor hits the rim of the bullet, it in turn hits this part. And this part not only is fit into the slide, it's also held by your firing pin, loaded with a spring. So the firing pin spring allows the pin to go back and forth. It also allows for some shock absorption in the retention plate. And it also allows for some shock absorption in the extractor claw, which is why you want this thing to be able to move a little bit back and forth. You know, mine is pretty doggone tight. Wow, look at that. Let's put in. Let me see if I can get her to come out and clean this in a while. Usually this area is skipped. I need a flat. You know, toothpicks don't damage the micro finish. But do you see how the light glances off the front face of this extractor claw? It's kind of tapered. Oh, it's clocking on me. Hold on here. It's slightly tapered to accommodate the ejection. You know, you want the bullet rim to let go on the bottom part and rotate upward. You know, so it's at an angle. It's like this. So that the shell hits right about here. It hits high on the GI slide, what you want, because when the shell is held like this, and it hits the ejector and it sends it up like that, you end up having contact here, support here, and support here. So your bullet is clearing the ejection port under load. Now, take some time and think about that one. You want it under load. Well, why would you want it under load? The reason why you want it under load is so you don't prematurely wear your extractor claw. Because if it's not bearing on this bevel here of your ejection port, if you will, you know, if it's open and it just knocks the bullet out, and it knocks it out, all of that vibration from the ejector hitting the back of the shell then transfers directly into your extractor claw. So when that happens, you can pre-fatigue it if you don't have, I guess you can call it a loaded ejection, if you will, with a expended shell. The contact, the controlled contact out of the slide preserves the extractor. And like I was saying, it moves forward and back. Well, it's supposed to. Mine's kind of stuck at the moment. Come on, you. I'll push you down. There. Whoop. Yeah, toothpicks are kind of weak, but I don't want to create any kind of scratch in there. It's going to create a jam, because some people have a hard time understanding that if you change the way the bearing surfaces are on these guns, you can get a jam. You're asking for it, and you probably will get it. So, all right, here we go. Here it is, all cruddy and all. Let's see if I can get this guy clean. This part here, what you're seeing, you're seeing how it's shiny here and there. That's a wear pattern. That's what you want. It tells you what's going on in this gun. You know, it's telling you. It's not saying, hey, look, you know, but you can visually tell that it's communicating that it's operating correctly. We got even wear areas on the top and bottom of the slot. So what we're seeing here is the bite marks from that. So this guy is like, you're right there. There we go. It's like that. Got a little wiggle, not much. When the firing pin hits this guy, it's moving forward and back. How do I know that? We're seeing some shine right here. And that's a bearing surface on that knuckle. The inside knuckle, not so much. This knuckle, absolutely, that's a bearing surface. So, you know, eventually it will wear to your slide and it'll marry itself in there, which is beautiful. That's exactly what you want. You know, you want all your bearing surfaces to cradle in and do the best job they can do. All right, so when we get to the claw, we can see in the light how it's angled. Right here, it's filed more towards the claw to expose more of the claw, and you can see that it's tapered this way to accommodate the feed. And then you can tell right here it's also slightly rounded, so the round can move on that surface. So, you know, when you're feeding, let's see here, skateboarding up the feed ramp, into the chamber. Okay, now you fire the gun, it's starting to come back, it hits the ejector like this, it lets go there, and goes out the ejection port. It's very dynamic. On external extractor claws, that's hardly ever in consideration. Usually they might bevel this area here, you know, and then they'll call it good. But a lot of that reliability that happens during locking and unlocking and then the loaded release of the expended shell through the GI ejection port isn't accomplished in a lot of modern 1911s. So you end up with a jam-o-matic, because open ejection ports, pre-fatigue extractors, and they knew what they were doing when they did it this way. Except that it's time consuming. So most people either don't understand, don't take the time to understand, they don't have the patience. But if you do this, you can be very successful at your, and accomplish a really, really reliable gun. And getting back to doing the, where you drop the bullet into the chamber like that and you snap her down, I don't want to do it on this one. Your claw profile on the front has to be right, so you don't break it. And if you look at the way the light dances on this thing, it's at an angle, and it's all surrounded. The top of the claw and the bottom of the claw. It's rounded, so if it hits here, right here, just bloop, comes right over with little effort whatsoever. It'll come over like you want it. And also, because it forces this thing to move, to move outward in a manner it wasn't designed for, like that, puts a tremendous amount of pressure in this area here, and the part can snap in two, it can break. I know that this extractor is machined because I could see tooling marks on it. See that right there? Those little tooling marks? This is not a MIM part. If you have a MIM ejector, throw it in the trash and get yourself get one that's bar stock. This is bar stock, and I wasn't going to use it because it was a auto ordnance part, and I was pretty biased. So then I said, well, hey, maybe I'll make it good and I'll see how long it lasts, because I'm just going to try to break this gun. Because if I could make it so it can't break, then I know I can rely on it. And I'm telling you, it's been well over 1,000 rounds, and I haven't been able to break this part at all. And if you have something that's bar stock and it's not a cast part and it's not a MIM part, MIM parts, you'll see like circles on the profile, and you want to throw those in the trash and get yourself something that's bar stock. Bar stock is about as good as it gets for now, because they don't make these out of spring steel, probably because it'd be hard to set these things. So that's what it is. And one other thing, I know this is a lot to take in, and it really is. And you could pause it and break it down and leave questions in the comments, about this stuff. And don't be embarrassed, because even the professionals overlook this stuff, or they don't understand it. It's not rocket science. It's pretty easy to me, having over 20 years experience with this stuff, and I know it like the back of my hand. And if you give me a piece of junk one, I can make something incredibly good out of it without buying a whole bunch of parts. Custom parts, so, but I want you to be able to do this too. It's no consequence to me if you do or if you don't, but knowing this, people are going to end up making better guns, and we all want better guns. We don't want a Jam-O-Matic, because a lot can go wrong if you don't pay attention to the details, and just shooting the crap out of a gun, isn't going to break it in if it doesn't already work out of the box. You get these guys that say, hey, you got to put like 500 rounds or 800 rounds before it breaks in. What they're telling you is they're not taking their time with their guns. And if your gun requires a break-in period, leave it there. It's not worth your time, because it's going to be expensive. And nobody wants an unreliable gun, and you want to enjoy your experience, and you want it to work when it matters. You want to pick it up and blast it and not have any issues with parts burring up, sticking, catching, none of that. So now we get to the next issue that's always, always missed. No matter whose gun you buy, if it's not built by me, then it doesn't have this. And what you're seeing here at the extractor claw, right here, how it's radial used this way and reduced. So this guy here doesn't come out squarely. It's tucked down and rounded in. And the reason for that, you see that? Can you see that? Yeah, I know you can because I can see it. Pay attention to that profile. Because what that is for is when you shoot a lot and your recoil spring gets tired. All right, it gets tired. All right, let's get this guy here. This guy here. Cheers. Okay, I gotta get that link pin there. All right, oops. There we go. There we go. So what happens is as you continue to shoot this thing, and it's all bam, 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 and this thing vibrates because there's some space in your bushing. You know, when it goes forward right here, the bushing's not supposed to pull the barrel, but when it goes forward, the bushing's loaded this way, and then when the slide comes back down here, and it smacks the frame, this thing starts to jiggle and wiggle, and then when that happens, that space that's there, that chatter, that's necessary, because if you don't have that chatter, you're going to end up with a barrel that wears the slide. It'll start what they call barrel springing, and it'll wear the top of your barrel and your slide, and you'll end up with a gun that jams. So that chatter, when it vibrates the barrel like that, it's like bam. It's all because, you know, maybe your recoil spring is wimpy or overused. That vibration that you see, you know, will cause the hood to vibrate right here, especially if your link pin is loose. I've talked about this in other videos. Your link pin right here, if this guy gets loose, you're going to get a lot of vibration when your barrel hits the frame bed. And we can see a little bit of the slide wearing on my barrel in healthy ways. That's fine. Nothing wrong with that. But what happens is, you know, a loose link and pin, a lot of side to side, and when that hits the frame bed, the vertical impact surface that's supposed to slow it down, which is kind of ridiculous because you're going to give it up eventually. You know, as you continue to shoot this thing, it's going to continue to trail back until it finds, you know, a cradle that it's happy with right in here. So if you're building guns like these custom race gun manufacturers do, or maybe you're doing it for a hobby, and then you set your link how you want it, and then it's kissing that frame bed, you know, where you want it. When this stuff starts to wear, it's going to come back, it's going to get hit harder, and it's going to really flatten that vertical impact surface that you were trying to set. You know, the one that in all the gunsmithing books that have like a specification, you know, to tell you that you did everything right. Well, it's not right. Because when that barrel doesn't come to a stop and it can work its way back, it's gonna pre-stress your link and your pin, and then you're gonna end up with a lot of chatter there. And what happens is when that chatter happens, it's gonna vibrate, it's gonna hit the top of your extractor claw right there, and it's gonna burr up, and you're gonna end up with a jam-o-matic. And I've seen it happen. It's happened to me quite a few times. So it doesn't matter if you go buy a Colt, Delta, whatever, Nighthawk, whatever, Dan Wesson, whatever. If it's not like that, and you shoot a lot, your gun's going to end up eating your extractor. This part takes a tremendous amount of abuse, and it's the most misunderstood, improperly fitted part in any 1911. And so that's the basis of my video. I hope you liked my video. Don't forget to like and subscribe so you don't miss out. And, well, cheers.